In this video, I want to have a look at another example of solving simultaneous equations where one of them is non-linear, but this example is a little bit harder than the last one. So in this one, we're going to have the circle x squared plus y squared is equal to 40, and we're going to have the straight line y equals x minus 4. So the first thing we do, again, always, is number them, so equation 1 and equation 2. Now we're going to substitute in. In our last example, it didn't matter which one we substituted in where, but in this one, it's going to have to be that we substitute equation 2 into equation 1. And that's because we've got y equals x minus 4, and we can put that in here. Whereas in these ones, we only have x squareds and y squareds, and we don't have anywhere to substitute them into equation 2. So we're going to do sub 2 into 1. So we've got x squared plus, now it's y squared, but because y is x minus 4, it's going to be plus x minus 4 squared is equal to 40. So now we want to expand this part out, which would give us x squared plus x squared minus 8x plus 16 is equal to 40. So if you need to write that out and figure out that expansion somewhere off to the side, do it to make sure you get it right. Do not forget that middle term or the whole thing will come out wrong. Then we're going to simplify this. So x squared plus x squared is 2x squared minus 8x plus 16 is equal to 40. We'll get rid of this 40 over here, so we'll subtract it off both sides, and that would give us 2x squared minus 8x minus 24. 24 is equal to 0. Now before we start to factorize it, it's a good idea to notice that these numbers are all even numbers. They're all divisible by 2. So we can actually make this a little bit easier for ourselves if we go through and divide every term by 2. So we'd end up with x squared minus 4x minus 12 is equal to 0. And now we can factorize. So we'd have x again. We need to be looking for two things that multiply to give minus 12 and add to give minus 4. So that would be 6 and a 2, and the 6 would have to be negative, the 2 would have to be positive, which is going to give us, if we solve each one, either x is equal to 6 or x is equal to minus 2. Now again, that's given us our x coordinates only, so we need to substitute them back in. Equation 2 is probably going to be a little bit easier because we're just working with x's and y's instead of all the squareds. So let's sub x equals 6 into 2. We'll end up with y equals 6 minus 4, which is 2. And if we do the other one, sub x equals minus 2 into 2, we'd have y equals minus 2 minus 4, which is equal to minus 6. So our points of intersection are 6, 2, and minus 2, minus 6. Again, we can graph them and double check, and that would look like this. I had to sort of squish it in there a little bit, but you can see that the points of intersection are at 6, 2, and at minus 2, 6 down here as well.